BLDC fan. Yes, that's the buzzword everywhere. High on customer preference list. And rightly so, because they combine efficiency and economy. With longer life, cool performance, low energy consumption, these fans have taken the world of electronics by storm. In this short presentation, we will look into the inside of these fans. We shall, in simple and non-technical terms, try to give even the layman an idea of the working and advantages of BLDC fans. Here is the simplified graphics. Don't worry if it appears complex with unfamiliar terms. We will explain in simple terms the features, and it is easy for anyone, even non-technicals, to grasp the essential idea. First, the expansion of the acronym BLDC. BLDC. Here, the letters B, L stand for brushless. That is, B for brush and L for less. And DC is, of course, direct current. So, BLDC, the full form is brushless direct current. Normally, fans or motors have carbon or graphite brushes. We shall see what the brushes do and how the same is achieved here without any brushes. First, take a look at the earlier fans or any motors with brushes. Although we are using the term brushes, they are not at all like the brushes used for painting, nor like our toothbrushes. They are just pieces of carbon or graphite. Well, what do the brushes do? You can see there are two split rings or two half rings. These split rings are called commutators. The most important thing is, the split ring commutators rotate with the coil or armature, but the brushes do not rotate. Thus, after every half rotation, the brushes exchange the split ring with which they connect. If ring 1 is with brush 1 and ring 2 with brush 2, then, after half a rotation, ring 1 shall be with brush 2 and ring 2 with brush 1. So, the essential work of commutators with brushes is to reverse the direction of current flow and thus keep the coil winding armature complex always rotating in the same direction. Here are the basic components of a brushless DC fan. 1. The rotor, the rotating part, that includes permanent magnets. 2. Stator, the stationary part, that includes the coil windings. Note that, here, the magnets rotate, while the armature coil does not. Also, the magnets are always permanent magnets, not electromagnets as in some earlier non-BLDC fans. 3. Electronic controller replaces the mechanical brushes found in brushed motors. So, it is the electronic unit that does the work of the brushes. Now, a short explanation on its working principle. Instead of using brushes to switch current direction, electronic circuits, commonly a Hall sensor and driver IC, control the current to the stator coils. The controller energizes the stator coils in a specific sequence to create a rotating magnetic field, causing it to spin in a fixed direction, say, anti-clockwise. So, the blades always rotate in one direction, thanks to the electronic part, instead of the commutators and brushes. To summarize, we have shown the two motors, brushed and brushless, side by side. In brushless DC, an electronic sensor and IC, or integrated circuit chip, replace the commutators and brushes. Also, while armature rotates and magnets are static in brushless fans, here it is the opposite. The magnets are rotating and the coil windings are static. And this is the feature that gives a definite edge to brushless fans over conventional fans, as we shall see. Why the craze for these brushless fans? Quite rational and sensible. Wise decision it is to prefer brushless fans. Here are the main advantages of brushless operation. 1. No friction from brushes, hence less wear and tear, which means longer life. 2. Quieter operation, no contact noise, hence noiseless. 3. Higher efficiency, better use of electrical energy, which means lower current consumption. 4. The rotor, that is, the rotating part, is typically the fan blade assembly. The controller adjusts speed based on input signals like temperature sensors in a computer. Some fans have PWM input, that is, pulse width modulation input, for finer speed control.